Okay, here we go. This is the section 5.2 Algebra 1 instructional YouTube video. Today we're going to be talking about solving a system of equations, system of linear equations, using the substitution method. So that's our learning target, and basically when to use this method and how to use it in different situations. That's what we are learning about today. So I'm just going to do a few examples basically. So here we have a system y equals 3x minus 8, and then 2x minus 4y equals 2. So our goal, remember, for a system of equations, is to find the x and y number, the coordinate point, that satisfies both equations. In other words, if I put the numbers in for x and y, both of these equations would still be equal on each side. So to do this, say, well, I notice this is y equals 3x minus 8. That means y and 3x minus 8 are the same thing. So what we're going to do is we're going to assume that there is a solution here. And I'm saying, all right, y and 3x minus 8 are the exact same thing. That's what it means when they're equal. So I'm going to take the 3x minus 8 and I'm going to replace the y in the other equation with the 3x minus 8. So that gives me 2x minus 4 times, instead of times y, I get times 3x minus 8. And then that equals 2. All right. So now I have one equation, and now there's no more y's. So what I did is I said y is equal to 3x minus 8. So instead of a y, I substitute the 3x minus 8. I substitute in whatever y was equal to in the other equation. So now I'm going to solve this equation for x, and I'm going to get x equals some number. So here I'm going to distribute. When you are distributing, make sure you're identifying if it's a positive or negative. Are we adding or subtracting 4 of these groups? Here we're subtracting 4 3x minus 8s. So we get 2x minus 12x, because negative 4 times 3 gives us negative 12. And then minus 4 times minus 8 makes plus 32. So here, I have 2x minus 12x plus 32 equals 2, because I distributed that negative 4 through. So now we're going to solve. So I can combine like terms. 2x minus 12x is going to give me negative 10x. And then I can undo that plus 32 by subtracting 32 on each side. So I get negative 10x equals negative 30, because 2 minus 32 is negative 30. And then I just divide by negative 10. And that gives me x equals 3. All right, so we found one part of the solution. We found the x number. Remember, what we want to find is the coordinate point, 3 comma something, that works for both equations. So what we do is we go back with this x equals 3, we go back into either of the original equations, either one, but we're going to pick the easier one. We're going to say, well, x is 3, so then y equals 3 times 3 minus 8, because I replaced the x with a 3, with what it's equal to. So here I get y equals 3 times 3 is 9, minus 8, which is 1, which means the y value is 1. The x value is 3, the y value is 1. There's your answer. We can also double check our work. We can take the other equation, say, hey, what's 2 times 3 minus 4 times 1? Right? Well, that's 6 minus 4. That's 2. And we wanted it to equal 2, so we're happy. This point, 3 comma 1, does in fact work for both equations. All right, let's do another example. So example 2, we have x equals negative 1/2 y, almost wrote an x there, plus 5. And then 6x minus 5y equals negative 18. All right, so when we're doing this, we look at both equations, we're like, all right, do we have an x equals or a y equals? Here, we have an x equals. In this problem, we have y equals. This one, we have x equals. So here, instead of replacing the y, like we did in this problem, we're going to replace the x, because it's x equals, so x and negative 1/2 y plus 5, those are the same thing, they're equal. So I can replace or substitute a negative 1/2 y equals, plus 5 for the x. So I get my new equation that's only going to have y's, no x's. So I get 6 times negative 1/2 y plus 5 minus 5y equals negative 18. And then here I'm going to distribute. This gives me 6 times negative 1/2. It's going to be a negative, positive times negative. Remember, when we're multiplying by a fraction, it's multiply by the top number, divide by the bottom number. So 6 times 1 is 6. 6 divided by 2 is 3. So we get negative 3y plus 6 times 5 is 30. And then minus 5y equals negative 18. All right, now combine like terms and solve for y. Boom, boom. We've got a negative 3 and a negative 5. That gives me negative 8y. I'm going to get rid of this plus 30 by subtracting 30 on each side. So undo that plus 30. Negative 18 minus 30 is going to get more negative to negative 48. So now I have negative 8y equals negative 48. I'm going to divide by negative 8. And that gives me y equals 6. So for our coordinate point solution, we have a y number of 6. Now we need to find the x number. So just like we did before, we're going to take this partial answer, y equals 6, and we're going to replace y with a 6 in either equation. You could put it in here, you could put it in here. This one's going to be easier because it's already x equals. So here we go, x equals negative 1/2 times 6 plus 5. We're replacing the y with what we got for y. So x equals negative 3 plus 5. Negative 3 plus 5 is 2. So x equals 2. So the solution is 2 comma 6. X is 2, y is 6. Okay. This is what we did in class for our lesson. Now, I'm going to throw a little bit more challenging problems at you, because it's good to challenge yourself a little bit. So we got 3 more examples to go over. Right, we could have checked the 2 comma 6 and seen that it is in fact correct, right, by replacing the x with the 2 and the y with the 6 in that second equation. Could have done that, I didn't. It's always best, if you're getting graded on something, to check your answer. Or even if you're not getting graded, if the answer means something, you should check it. All right, we're gonna do a few problems here. Let's say we have 2x minus 3y equals 6, and x plus 2y equals negative 11. That's one problem. Let's say we have y equals 3/5, x plus 7, and y equals 3/5 x plus 3. And lastly, we have y equals 2/3 x minus 6, and 3y equals 2x minus 18. So these are each their own systems of equations. We'll do this one together. I want you to try these on your own, and then we'll go over them. Okay. Starting here. This one's not x equals or y equals. So we don't have like a simple way to just do substitution here. So what we have to do is we want to solve an equation to get x equals or y equals. We want to make it look like the previous problems that we just did. So looking at these, right, if I wanted to solve for x in this equation, I could like add 3y over and divide by 2. If I want to solve for y, I could subtract 2x and then divide by -3. If I want to solve for y here, I could just subtract x and then divide by 2. If I want to solve for x here, I could just subtract 2y. So we look at these options and we're like, what's the easiest one? What's going to give us the least number of fractions, right? Because fractions just make it a little bit more complicated. What's the most simple? The most simple is to solve this equation for x, because we have a 1x here. So I'm going to solve x plus 2y equals -11 for x. And to do that, please go minus 2y on each side. And because y and -11 are different, that gives us x equals -2y plus 11. So that's what x is equal to in our second equation. So now we've got we have the same system of equations. We just took the second equation and rewrote it, so it's x equals now. So we can do what we've done previously. We can say, hey, this is x, so I'm going to replace x with a -2y plus 1. I get 2 times -2y plus, not 1, plus 11. And then minus 3y equals 6. Distribute the 2. Right? Combine like terms, you get a -7y. Subtract a 22. -2y equals -14. Wait a second. Let me make sure I didn't goof. It's supposed to be a -11. That's okay. It was a -11, this should still be a -11. Yeah, we'll keep it. I goofed, right? I goofed. This is a -11, this should be -11. So this should be -11. This should be -22, which means we're going to add 22 to each side to get a -28. My bad. Right, then we divide by -7, and we get y equals 4. So for our solution, we have a 4 for our y number, and we can go back to any of these versions of these equations and replace the y value with 4 to find the x number. Because remember, the solution is the coordinate pair x number comma y number. So I'm going to go to this one that I already solved, right? X equals -2 times 4 minus 11. Did I goof again? Maybe, maybe not. We'll see. And this gives me -8 minus 11. X equals -19. So -19 comma 4. Ooh, let's see if this actually works. This isn't going to work. Where did I goof? I goofed somewhere. How did I goof this up? Rats. That's where I goofed. Check it out. 22 and 6, that makes a positive 28. Divide that, that makes a -4. -4, -4, positive 8. -3 is the x number. I knew I goofed because if I put 19 in here and I put 4 in here, right? 19 for x, 2 times 19 is 38, minus 3 times 4, so 38 minus 12 doesn't equal 6, because it's like, rats, I goofed on camera. That's okay, we all make mistakes, it happens. Even when you're a math teacher doing a YouTube video. So just to dial it back, I made 2 mistakes on this one. Step 1, we want to say, hey, it's not x equals or y equals, so we make it x equals or y equals by solving for x or solving for y. To do that, I subtracted 2y from each side on this equation to get x equals negative 2y minus 11, because it was a negative 11. Then I replace the x with negative 2y minus 11. Distribute to get negative 4y minus 22. Minus 3y equals 6. Add the 22 over, combine like terms. Divide by the negative 7. Get your y value. Y value is negative 4. Go back up here. Replace the y with the negative 4. Right, it's a negative 4. That gives me a positive 8 minus 11 equals negative 3. There's your answer, negative 3, negative 4. Sorry for the goof ups. It happens. All right, let's look at this one. Try this one on your own. See if you can do it without goofing up. So go ahead and pause the video. Boop. Right down there. Boop. Okay, now let's look at it together. It's y equals and y equals, so we can substitute this for that y. Y is equal to 3/5 x plus 7. So I can say, instead of this y, 3/5 x plus 7 equals 3/5 x plus 3. Well, remember, we want to get the x's on one side. We've got variables on both sides of the equal sign. So I'm going to go minus 3/5 x. But that cancels out to 0 on both sides. We get 7 equals 3, which is not true. 7 and 3 are not the same number. So here we say there's no solution. And remember, from section 5.1, when we're talking about solving by graphing, right? We're trying to find where these two lines intersect, where they cross. But if we look at these two lines, they have the same slope and different y-intercepts. So one of them starts at 3 and goes up 3, right 5. The other one starts at 7 and goes up 3, right 5. So we get two lines that are parallel lines, and we know parallel lines never intersect. Well, on a flat surface they don't. So here these parallel lines will never cross. In other words, we get no solutions to this system of equations. There is no x comma y pair that's going to work for both of them, because this one is always going to be 4 bigger than the other one. All right, let's look at the next problem. Here, y equals 2/3 x minus 6, and then 3y equals 2x minus 18. So here we have a y equals, so I can take what y is equal to and replace that y. So I get 3 times what y is equal to, 2/3 x minus 6 equals 2x minus 18. And then I can distribute the 3, right? That gives me 3 times 2 is 6. 6 divided by 3 is 2. So 2x, or just 3 divided by 3 cancels, we just have 2. So 2x minus 18 equals 2x minus 18. You'll notice these are exactly the same. We could go one step further, go minus 2x, right? Negative 18 equals negative 18. No more variables, exact same number on both sides. This means we have infinitely many solutions. The reason we have infinitely many solutions is because if I take this equation here, y equals 2/3 x minus 6, and I multiply each side by 3, that gives me 3y equals 2x minus 18. These two, they're the same equation. And if you have two equations in a system that are the exact same equation, that means every x comma y that's going to work in this equation is going to work in that one, because they're the same equation. So we've got 3 situations now. We could have one solution where the two lines cross. We could have no solution where we have parallel lines, in other words, same slope, different y-intercepts. Or we can have infinitely many solutions where the two equations are just the exact same equation, but look a little bit differently because maybe one of them is multiplied on both sides by a number. All right, so that is it. Hopefully this will get you through all your 5.2 homework. Thanks for watching. Go Bulldogs!